review of FOIL. If you can already do this, go ahead and do it at your desk. For the rest of you that are saying, I forgot how to FOIL, watch up here and I'll walk you through the steps. What we do is we take our first item and we distribute it to every item in the second set of parentheses. But notice, I only drew one arrow so far, because I'm going to do the math that goes with that one arrow. X times X is X squared. After I do that, then I get to draw in another arrow. X times negative 3 is negative 3x. So the x now has gone to everything in those second set of parentheses. Now I'm going to do the positive 2. 2 times x is positive 2x. And I'll do that one more time. 2 times negative 3 is negative 6. Now, if you can do this problem without drawing the arrows in, I'm perfectly fine with that. You do not have to draw them in. But if you're the person who needs to draw in the arrows, draw in one, do the math. Draw in another, do the math. Do not draw all 4 arrows in and then say, what do I do first? I get that every year. Draw one in at a time. But I still need to do one more thing. Combine like terms. X squared minus x minus 6. Any questions on FOILing? No? Well then, let's make sure you've got that. Go ahead and do that problem by yourself. So if I'm FOILing this, I'm going to take the 2x times x, which is 2x squared. 2x times negative 4 is negative 8x. Negative 7 times x is negative 7x. Negative 7 times negative 4 is positive 28. Now I'll combine my like terms. 2x squared minus 15x plus 28. Raise your hand if you got that. Excellent. But I want to show you a way to double check your answers quickly in the calculator. Now this way I'm actually showing you will work if you have to retake these notes for multiple choice. You can actually stick them right in, and you don't have to actually FOIL it or factor them if it's multiple choice. This way also works for anybody taking the SAT. It's also a great method. Or anybody that has to take my final, this is also a method to do. So what we're going to do, we're going to pull up our lovely calculator and clear anything that's on there. And go to your y equals screen. In y1, I'm going to type in the original problem with the parentheses. So parentheses 2x minus 7 parentheses, parentheses x minus 4 parentheses. And then in y2, I'm typing my answer that I got. 2x squared minus 15x plus 28. So some of you may have that in there. The reason is because you'll actually see here in a minute once we go over a few other things. Once you've typed them in, go ahead and hit graph. So I'm just waiting a second while people finish typing in. It is a parabola. Actually, could I tell that it's a parabola before I even graph it? Anybody know how to tell that it's a parabola right away? I see it squared, it's got to be a parabola. You don't even have to graph it. You should be able just to say, hey, there's a square. It's a parabola. What if it had not had the squared? What if it had just been negative 15x plus 28? What would you automatically think it is? Yeah, you can tell that's a line, right? Without even graph it. But if I graph it, there's my lovely graph. How many parabolas do you see? I don't know where the other one is. Anybody have an idea? Yeah, we're thinking it's on top, but there's only one way to check, because how do I not know, or how do I know that the other parabola is maybe over here? You know? Way over here, right? Or maybe the other parabola is way up here. Okay? So here's how to check it very quickly. You hit second, and you hit graph. And you look at your table. Do your y numbers match up? Then you did it right. That means it is on top of each other. It's the same exact y value. That's a quick, easy way to check, isn't it? Perfect. So we're heading back to your spiral notebooks. We're going to actually now cover the first step of factoring. Foiling is actually the opposite of factoring. So you may be saying, why do I need to know how to factor? Factoring helps us to find x-intercepts of a graph, also known as zeros, also known as roots. All three of those are synonyms. Okay? So greatest common factor is the first step of factoring. And eventually, by the end of this week, I'll walk in and I'll say, what's the first step of factoring? I'm going to hear GCF! And you guys are going to get excited over that because you know that first step of factoring is GCF. So when you're doing factoring, you're looking for a number first that divides into everything. Is there a number here? What number can you divide into both 1 and 3? 1. Number. Okay? So, if it's just the number 1, we're not going to write it. Do they have a letter in common? X. Okay, and what's the smallest exponent on the X? 1. See how there's a 1 right here that they forgot to write? So it would be x to the first. That's actually the GCF on this problem. So now, to finish factoring it, I just ask myself, x times what is x squared? That's correct. I needed one more x, right? X times what is 3x? Negative 3. So I already wrote the minus sign. So I'll just write minus 3. And that's it. That is all there is to greatest common factor. Make sense? Yes. Okay. We're going to do 5 of these all together. So there's 1. We're on problem 2. So I'm going to walk you through the steps again. So the first thing I look for is a number that divides into both 3 and 9. 3. Is there a letter in both that's in common? What is the smallest exponent? 1. Now you can write the 1 if you want. You don't have to though. Some of us know it's 3x. You don't need to write it that far. So now you ask yourself, 3x times what is 3x squared? 1x, right? I've already got the 3. So 3 times 1 is 3. So I don't need to write that 1. See how if I distribute the 3x to the x, I get back that 3x squared from the beginning, right? That's also a quick check. Got the minus sign? If it had been a plus sign, what sign would I have written next? A plus, okay? 3x times what is 9x? See, I already have the 1x there, and I only need 1x. I don't need to put any more there. Any questions? Okay, problem 2 we're doing well on, right? Like I said, 5 problems. Let's do problem 3. No, it's not that difficult, I promise. I just want to make sure we can combine everything we've talked about. Now, raise your hand if you can tell me what number goes into 8, 12, and 28. Amelia. 4. Raise your hand if you didn't know it was 4. Jenny. Okay, Jenny, you didn't know that. So, hey, you guys may be laughing, but I purposely asked her to raise her hand on that one. So don't make fun of her. I said, hey, Jenny, raise your hand when it gets to this problem. Because I want to show you how to come up with the number 4 using the calculator. Because if the number had been 872, 6,975, and 4,872, would you have been able to come up with the number? I would. But before I actually show the calculator, you're going to need to write down in your notes GCD. I know, D, because it stands for greatest common divisor. So, I'm going to get back to the home screen. If there's anything on the home screen, clear it. Everybody good so far? Okay. So, it's actually under here somewhere. I don't know where it is exactly, and I don't really care to know. Instead, I've got this thing called a catalog. Anytime I don't know where something is, I look under the catalog. So I'm going to click second 0. And notice the catalog's actually in ABC order, right? Alphabetical. Well, I don't want to have to hit the down arrow until I get to G. So if you notice, the letter G is above the word tan. You see the letter G in green? Is this green? Yeah. Okay. So I'm just going to click the tan key, and it automatically takes me to the G. And now I can just hit the down arrow key once to get to GCD. Okay? Now, under greatest common factoring, you can only do 2 at a time. So I can't type in 8, 12, and 28 or 24, whatever that number was. I can only do 2 of them at a time. So let's do the first two, 8 and 12. So you type in 8. You type a comma. The comma's up here beside the parentheses. And then you type a 12. Click enter. So far we found it's a 4, right? So now what we're going to do is we're going to use that 4 and we're going to use the number 28. You can't use a negative, by the way. It will always fail if you try to do a negative. It will always fail if you try to do more than 2. It'll give you an error message. So here's my quick way of getting this back up. Second, enter. There's my problem again, isn't it? So I'm going to go over to the number 8. I'm going to type 4, comma, 28. And look, Jenny, I got the number 4 that way. How convenient that you guys filled it in. Okay, now, you guys may be laughing because that was an easy one to actually come up with, right? So let's go ahead and finish it now. So we know it's 4. Is there a letter in all of them in common? What is the smallest exponent? So I'm going to write 4x cubed. To make this a little easier, 4 times what is 8? 2. See how you have 3 x's right here? You need 5 x's. So you need x squared. You need 2 more to make that. Am I making more sense? Okay. 4 times what is 12? How many more x's do you need? Just 1. 4 times what is 28? 7. And you don't need any more x's because you have x cubed and you only need x cubed. And that's your answer. Does that make sense? All right. Like I said, 5 total problems. We have 2 left. So here's our 4th problem. Ooh, I don't like this one. Raise your hand and tell me why I don't like this one at all. Oh, okay. Not in order of my exponents, right? I like my highest exponent first. I like my next highest second. I like my third highest. Kind of like if I'm counting money. I want to see the hundreds first, then the 50s, then the 20s, then the 10s. If I have them all mixed up, 1s and 5s and 20s and 10s, and it's hard to count, isn't it? It really gets tough. So I'm going to rearrange this. I'm going to put the negative 50, oops, 50x squared. Reason it's negative, it has a minus sign in front. Plus 100x. Does that make sense? All I did was rearrange it. I put the highest exponent first, the next highest second. into both 50 and 100? 50. So if you knew that, did you have to use a calculator? If you didn't know it, then use it, right? Now, since it begins with a negative, I'm going to pull out a negative 50. If it begins with a negative, pull it out. If it begins with a positive, you begin with a positive. Okay? Is there an X in both? Yes. Smallest exponent is a 1. So far, okay? Negative 50 times what is negative 50? 1. You'd never be writing a 0 on these. Because 0 will cancel everything out. How many more X's do you need? 1. Negative 50 times what is positive 100? Negative 2. Notice that when you pulled out the negative sign, both of the signs inside here did what? They switched. So if you pull out a negative, all your signs switch. I'll repeat that. If you pull out a negative, all your signs switch. One more time. If you pull out a negative, all your signs switch. Now, most of my other students know, and it looks like half of you know, if I repeat something at least twice, you should write it down. It's like one of those things that you'll miss on a homework assignment, usually, if I don't repeat it. Now, last problem. This problem you do on your own. Go for it. We use the calculator, and we find out it's 11. Is there an X in both? Smallest exponent? Uh-oh. I have absolutely no clue. 11 times what is 220? I have no clue. I have a calculator though in front of me. What can I do? Divide 220 by 11. You're allowed to use the calculator. So you will find out that it's 20. How many more X's do you need? 11 times what's 77? Any more X's? Done. Nope. Bogey 5 problem. Problem 5. Okay. So this week's a little different than normal.